Yeah, good morning, everyone, and thank you for this opportunity. My name is Benjamin. I am a PhD student at University College Dublin, Ireland. I've landed on my PhD. This is one of my key objectives in my research. WRF Urban Schemes Assessment of UHI and its stress over a tropical humid city of Lagos, Nigeria. So briefly, I will introduce the topic and then the key research questions, the methods, and then some evaluations of the urban schemes that we have in WRF, and then the heat stress in particular using e-meters. So basically, with populations generally worldwide have been unprecedented, especially in Africa. And then the most importantly is that African cities or African countries or developing countries are not going to stop in the future, unlike other continents. And we have seen some unprecedented growth in this in West Africa in particular, in terms of population and population density. And then we see that from our literature, we found that there have been scarcity of urban climate studies in this part of the world, despite the fact that this part of the world are most vulnerable to the impact of global warming and climate change. So one of our key research question here is that we want to see how different WRF urban schemes compare in reproducing key meteorological variables that is needed for um, relevant heat stress studies. So part of the problem that we have in developing cities is that there is lack of high resolution data that can be used for urban climate study and heat stress analysis. So with the advent of technology and improved state of the art models and transferability of these models from the west down to the tropical area, we can actually use these models to simulate weather variables. Uh, Another problem is that these models they need representations of the 3D features that we have in the urban area, the three-dimensional urban features, which is a problem in gathering this type of data. So with the advent of the local climate zone scheme, it is possible to use the urban canopy parameterizations of this scheme to drive all these models. So in our previous studies, we did a fieldwork on urban canopy parameters gathering from the field in the city of Lagos, and then we compare that with the generic local climate zone scheme. So in particular, we found that there is no significant difference between the two. So here we want to see which urban scheme is best in representing in simulating the heat stress variables. So, and then what is the pattern of heat stress within the urban area in Lagos, and what is the impact of urbanizations on the heat stress pattern? So, like I said, we taking the city of Lagos in Nigeria as a case study for the sub-Saharan African cities. Lagos is highly humid with high temperature all year round, and it is considered like a mega city of slums, large informal settlement. So, and over 50% of Lagos' 21 million residents live in informal settlement. So, our WRF model is configured with four nested domains, with the innermost domain at 1 kilometer. So, the outermost domain and all other areas are represented with the modest land cover. However, the innermost domain is we use the local climate map to represent the urban area. So now we have three set of simulations. The slab model, which is the default, and then we have the BEP model, and then the BEP model. The BEP and the BEP model are multi-layer schemes, unlike just the box scheme. So our goal here is to identify the best model that can simulate basic meteorological variables for urban climate studies. From so we did our evaluations on three stations. that are strategically located, two in the core urban areas and the one in Elizabeth C in a rural area. So, in terms of the head temperature from the three models, we found that the three models performed very well in simulating the diurnal pattern of local of air temperature. However, we found some underestimations and overestimations, which the reason could be the misclassification of the exact measurement locations in the model grid. And then in the relative humidity, general underestimations of RH, from literatures, we found that generally that WRF have difficulties in simulating the relative humidity, which could be as a result of the forcing data or the model parameterizations, and that WRF sometimes have difficulties in capturing evaporations and then the sea breeze effect. So, and then for the spatial mapping of the three schemes, so we compare the air temperature pattern of the three schemes. So we found that the BEM model was able to simulate, the multi-layer schemes provide a more evident urban heat island. As you can see, unlike the box scheme where we have something like largely homogeneous pattern of air temperature. So, and then in terms of the wind, we found that generally the BEM model produces weaker winds, which could be as a result of the new drag coefficient that we have in WRF simulation. And then the wind directions are well simulated, except some few stations. And generally, we found that uh, BEM model has the lowest normalized root mean square error. So we proceed with simulations with the BEM model. So this normalized root mean square error is uh, where the root mean square error were normalized for air temperature, wind, and relative humidity. So we did simulation of heat stress based on humidity. So humidity is a key heat stress index that is a function of air temperature and relative humidity. So, and then at daytime, we simulated the heat stress based on the local climate zones. We found that at daytime, there is no significant variations in the pattern of heat stress. However, the urban, we, at night, we have large and significant intra-urban variations. Suburban LCZ 6 and 9, which are suburban areas, have the largest variations in heat stress. So we look at the frequency of hot period within the local climate zones. So we found that the informal settlement, which is Elizabeth 7, have at night we have their most pronounced hot conditions. And at daytime, all the local climate zones experience some level of very hot conditions. However, we couldn't differentiate between urban and non-urban area. So even non-urban area, Elizabeth 6 and Elizabeth 9 have some very hot period, which could be as a result of high evaporation and high humidity in those areas because humidity depends on relative humidity as well and as well as air temperature. So what is the urban influence on heat stress pattern? So we simulated an heat stress with urban and then with no urban. So generally we found that at reduce daytime heat stress, particularly in the core urban areas. We found that with humidus heat stress, we found relatively cool uh, heat stress in the core urban areas. The reason for this could be as a result of the reduced humidity in the core urban areas. And then possibly because of the urban cool highland that we have at 1200, we can see we have some form of urban cool island, which could be as a result of radiation trapping, and then the sea breeze because it's a coastal city. So this could be responsible for the pattern of heat stress. that we have during the day. So generally, we found that WRF Urban, driven with the local climate zone scheme, could adequately simulate the local met variables, that relative humidity and air temperature that can be useful for heat stress analysis. And then we found that the BEP model is most suitable for simulating the local parameters that we need for this type of study. So, and then informal areas that is associated with unique type of building materials like uh, corrugated metals and all of that that have high heat capacity. They have the highest frequency of hot stress conditions. And then the urban influence could cause reduced daytime heat stress based on humidity in the core urban areas during the day. However, this has some limitations because it's only depend on the air temperature and relative humidity. So our future research might consider some field work to do some surveys on heat stress and then compare it with other heat stress indices. Thank you very much for this opportunity.
Thank you very much for this very nice talk. Does anyone have a question?